Now let's explore some properties of inverse functions. First, I need to find the inverse of this function. So I'm going to write y equals 2x cubed plus 1. And then recall that we need to switch x and y. So I have x equals 2y cubed plus 1. I now need to solve for y. To get y by itself, I'm going to use SADMAP again, or PEMDAS backwards. I can subtract 1 from both sides, so I get x minus 1 equals 2y cubed. After I subtract, I need to divide both sides by 2. So I get x minus 1 over 2 equals y cubed. And finally, I need to cancel out the cube. The opposite of cubing something is the cube root, so I'm going to take the cube root of both sides to cancel out that cube. This means that my inverse function, f inverse of x, is the cube root of x minus 1 over 2. Now, one important property of inverses is that they undo each other. So if I were to find f of, let's say, 2, I'm going to plug 2 into my function where I see x's, and then I know that 2 cubed is 8, and 2 times 8 is 16, and 16 plus 1 is 17. So when I plugged 2 into the function machine f, what I got out was 17. If I take 17 now and plug it into the inverse function, so I have the cube root of 17 minus 1 over 2. Well, 17 minus 1 is 16. And 16 divided by 2 is 8. And the cube root of 8 is 2. So what happened is when I took 17 and I plugged it into the inverse function, oh man, that was a crappy inverse function, but whatever, you get the idea. What I get out is 2. And so inverses really undo each other. They're opposites. Another important property of inverses is that they're symmetric over the line y equals x. Their graphs are. So if I go into my graphing calculator and clear out what was there, okay, I'm going to plug in 2x cubed plus 1. That was my f of x. And I'm also going to plug in the cube root of what was it? X minus 1 over 2. Now to do the cube root, I know the cube root is the same as the 1/3 power. So instead of thinking of this as the cube root of x minus 1 over 2, I'm going to put parentheses x minus 1 to tell it the top of the fraction, divide it by 2, and then raise it to the 1/3 power in my calculator. So you get parentheses and then parentheses x minus 1. There's the top of my fraction, divided by 2, and then I'm going to raise that to the 1/3 power, taking care to put parentheses around the 1/3 power so that my calculator knows that's all part of the exponent. I'm also going to graph the line y equals x. Now when I hit graph, you'll see here's my original function f of x. Here's the inverse function, the cube root of x minus 1 over 2. And here's the line y equals x. And sure enough, my graph is symmetric or equidistant from the line y equals x. So that's another important property of exponents. Now the reason y equals x is special is because it's the only line that when you switch the x and y coordinates, nothing changes. In fact, if I look in the table, oh man, my table's all crazy. Notice if I come over to the line y equals x, 3 is 3, 2 is 2, 1 is 1. It's the only line where I can switch x and y and nothing changes.